First year BE BTech, subject code 19MA202, subject name Calculus and Laplace Transform. Unit 5 Laplace Transforms. So outline of this topic is properties of Laplace Transform. Number 1, first shifting theorem. Number 2, change of scale properties. Number 3, divisible by T form. Number 4, multiple by T form. Number 5, derivative formulas. So here is the shifting theorem is an important 2 mark questions. Then change of scale properties, another very important one. These are using in the problems. Divisible by T, multiple by T form is important 8 mark questions. Then derivative formulas using this one in the end of this unit. Laplace transform by using differential equations. For that chapters we can use in the derivative formula is very important one. So first we shall go through first shifting theorem. If L of f of t equal to f of s, then L of e power at f of t equal to capital F of s whenever s goes to s minus a. So this one is multiple of e power at into function is given, means we can write e power at in terms of s goes to s minus a. Suppose here is e power minus at is given, means we can replace s goes to s plus a. This is nothing but Laplace transform formulas. We can replace where is s occurs, that place we can replace s minus a or s plus a given in the problem. Next one is change of scale properties. This one is a very important 2 mark questions. Statement is if L of f of t equal to f of s, then L of f of at equal to 1 by a into f of s minus, that is s divided by a, whenever a is greater than 0. So this one is anything. This one is a capital F of s by a form. Okay, so f of at equal to 1 by a into capital F of s divided by a, whenever a greater than 0. So we shall go through the proof here. If L of f of t equal to f of s, then by Laplace transform definitions we know that L of f of t equal to integral 0 to infinity e power minus st f of t dt. This is already basic formulas in Laplace transform. So using these formulas we can derive the change of scale properties. So here is we can replace t in terms of at. Similarly here is f of t in terms of f of at. Here is don't replace this one. This is a function exponential form, so don't replace here. So f of t in terms of f of at. Here is f of t in terms of f of at. So next, by using substitution form, take at equal to x, then t equal to x by a, then differentiate on both sides. So dt equal to dx by a. So replace this value from the above equations, then we will get f of L of f of x equal to integral 0 to infinity e power minus s into replace t in terms of x by a, then f of x into dx by a. So next we can take 1 by a outside here. So we get 1 by a into 0 to infinity e power minus, here is I can take x outside, s by a into x, f of x into dx. So this is of the form Laplace transform, integral 0 to infinity e power minus at into f of t dt form. Instead of t we can write x here, instead of s we can write s by a. Therefore L of f of at equal to 1 by a into f of s. S is nothing but s by a. This is a very important 2 mark questions. State and prove change of scale property. So next one is divisible by t form. So if L of f of t equal to f of s, then L of f of t divided by t equal to, we can write integral s to infinity capital F of s into ds. So here is we have one important thing here. 1 by t is given, is that is integrations form. Limit goes to s to infinity. So be careful here. So any problem they will be given 1 by t form, that is divided by t form, is we can replace 1 by t in terms of s goes to infinity. Next one is multiple by t form. If L of f of t equal to f of s, then L of t into f of t equal to minus d by ds into f of s, that is capital F of s. Suppose n number of terms is given means, so t power n of f of t is given means we can write minus 1 whole power n into d power n divided by ds power n into capital F of s. So suppose here is 2 is given means t square is given means we can differentiate with respect to twice. T cube is given means we can differentiate with respect to cube terms. Similarly for this case 1 by t square is given means we can take double integrations. S goes to infinity, again s goes to infinity into f of s, then ds form. This f of s is nothing but the given functions L of f of t form. Okay, these two are very important formulas we can write in the Laplace transform techniques. So next we shall go through the problem number 1. Find L of t sin 2t. So here is we can identify multiple of t into f of t functions. So this is a multiple of t form. So multiple of t means your formula must be in differentiations. So here is t power n is must be in 1. So your formula is minus 1 whole power n, then d power n divided by ds power n. So n equal to 1 means here is we get minus, then d by ds of capital F of s. So here is f of t is nothing but sin 2t. Then you can take f of s is nothing but L of f of t, that is equal to L of sin 2t. What is L of sin at formula? A divided by s square plus a square. Here is a is 2, so therefore we can write 2 divided by s square plus 4. Therefore f of s equal to 2 divided by s square plus 4. Therefore write the formula for the multiple of t form. Therefore L of t sin 2t equal to minus d by ds of, you can write f of s in terms of 2 divided by s square plus 4. Next we can differentiate with respect to ds. So here is we can write 1 by x form or u by v form. Suppose I can take 1 by x form means differentiation of 1 by x is minus 1 by x square. Okay, so here is I can write minus, so 1 divided by x square means s square plus 4 whole square. Again we can differentiate this s square means 2 times of 2s. Okay, so therefore we can write here is we have one minus, here is we have another minus. So minus of minus must be in plus. Therefore 4s divided by s square plus 4 whole square form. Or you can use u by v form. So u is 2, v is s square plus 4. So what is v square? V square is s square plus 4. Then differentiation of 2 must be in 0. Therefore this one is 0. Then minus 2 into dv form. Differentiation of s square is 2s divided by s square plus 4 whole square, that is v square form. So again we can write minus of minus must be in plus. Therefore 4s divided by s square plus 4 whole square. Next problem number 2. Compute L of t square into e power minus 3t. This is also multiple of t form. So therefore here is t square is given, n equal to 2. Therefore formula is minus 1 whole square d square divided by ds square into f of s. Here f of t is e power minus 3t. So first we can find f of t is, what is L of e power at? 1 divided by s minus a. Here is minus is given of 1 divided by 1 plus s plus a form. A is 3. So 1 divided by s plus 3. So d square by ds square. So here is we can differentiate with respect to twice. So this can be written as d by ds of, again d by ds of 1 divided by s plus 3. That is equal to d by ds of, so 1 by x, differentiation of 1 by x is minus 1 divided by x square form. So therefore minus 1 divided by s plus 2 whole square. So again differentiation of this one is, so minus 1 divided by x square means, so we can write 2 divided by s plus 3 whole cube form, or we can write u by v form. So we get 2 divided by s plus 3 whole cube form. Okay, so this is another important problem. Here is t square is given, so we can write minus 1 whole square, then d square by ds square into f of s form. So it's a very important formulas to finding the solutions. So be careful here. Okay, thank you.